welcome to today's webinar. My name is Andrew Eilers and I'll be going over today's topic of Intro to Time Calculations. Over today's webinar, we'll be going over what we're referring to when we're talking about time calculations, the information that you're going to need to do these time calculations and adjust them to be more accurate, as well as what do you do once you have that information. So the first thing we're going to go over is the reason why you would want to adjust your time calculations to actually have accurate numbers coming outside of the software. There's really two main reasons for this. The first one is for better scheduling and planning. As a user of the software and as a manager, it's definitely important to make sure that you're scheduling adequate amount of time for running programs at the machine. You don't want to overplan, and you definitely don't want to not give your operators enough time to run those programs. So for instance, you don't want to estimate that a job's going to take an hour when in fact it's actually going to take 2 hours to cut. On the other hand, you definitely don't want to have an issue where you give them 2 hours and it only takes 1. And then we have to figure out how to fill up that extra hour of time that we didn't plan for or account for. The other part is for quoting. Inside the software, we do have the ability to quote, and time calculations is part of that. So we do charge customers and quote based on how long it actually takes to cut those parts. And if you don't have that time, then you might be overcharging or undercharging. If your part is saying that it's going to take 10 minutes to cut out, when in fact it only takes 5, and you overquote, you might overcharge the customer and lose out on a quote. On the other side of that, if you plan that it's going to take 10 minutes to cut that part and it really takes 20, you're going to end up losing money on that based on the extra time that you didn't account for. So it's very important to make sure that your time is accurate for your quoting. That way you can be as competitive as possible. So first off, what do you need for accurate cutting times? So the first is going to be a workspace that will be ran on the machine. So ultimately you're going to make a program inside the software and then you're going to run it at the machine. Before you run it at the machine, you're going to want to make a report of the original time calculation. So you're going to print a report. Usually it's going to be your detail analysis, especially if you're doing time calculation. A layout detail report will work as well. Really anything that will show the amount of time that it's going to take to run that program. That way we have a reference for what we're actually estimating at that point. Then what we're going to want to do is take a stopwatch and actually go out to the machine, have it run, and see how long it actually takes to run at the machine. That way we have our estimated time and the actual time. Some other basic information that you're going to want is your pierce time information, how long it takes to do a head up, head down time, your rapids, feed rate, stuff like that. Just some of that basic information. That way we can plug those in and have very accurate numbers. So what's next once you have this information? What we're going to end up doing is adjusting values inside of the post file as well as the technology setup inside of the software. Both of these have their respective purposes. For the post file is going to be for your static values, no matter the thickness, material, or process that you're cutting at. So for instance, if I'm cutting 1/2 inch stainless steel on my machine and I'm also cutting a 1/4 inch stainless steel, the head up and head down times are going to be exactly the same. As for the rapids, the head up rapids are going to be the exact same between the two different thicknesses, as well as etching time and stuff like that. Things that won't really change between the different thicknesses. So for your post file, this is where we're gonna have a lot of our static values that will be consistent across all materials, thicknesses, and processes of cutting. The next we're going to go into is the technology setup. This is where we're going to adjust the feed rate and the pierce time based on the actual material, thickness, and the process that we're going to be cutting with. So for instance, we will have different cutting feed rates between the 1/2 inch and the 1/4 inch stainless steel that I referred to earlier. So some of the lines that we're going to change inside of the post file are around the 410 line section. The first one is going to be time calculation, whether or not it is on or off. In this case, because we want to have accurate times, we want to make sure that this is on, and this does get added to the estimated time calculations. Then we have other items in here such as the rapid feed rate and acceleration, which will be either in millimeters or inches, depending on the units that you're using. The vaporizing feed rate, which again is going to be in millimeters or inches, and this is if you have a laser, for instance, that's going to vaporize your material. Then we have of course, our head up and head down time, so rough estimate on what those are going to be. If you have a punch machine with reposition, how long does it take to reposition from one to the other? Your drop door, how long does a drop door take? And that does get multiplied by how many times we drop the door on the machine. If you have manual part removal for any reason where the machine has to stop and the operator has to get the part on the sheet and take it out and then start the program over again, at this point, how long does it take that, or an estimate? Part handler removal time. So this is going to be any time that we have an automated system for part removal and how long we want to give that. The other two most common ones are going to be your setup and unload time. So your start and end time. So how long does it take to put the sheet on the bed, to load it, start the program. And then your unload time, how long does it take to get the sheet off the bed so you can start your next job. All of these are going to be estimations. Of course, we don't expect you to have accurate numbers for this every single time, but just a rough estimate will be good enough for this. There are other options inside of here, depending on your machine, but these are going to be most of the most common ones that you're going to see. All right, and as for the post lines, that's something, again, that is going to be something that is going to be static across any nest, not reliant on the material thickness or the process. As I mentioned, your head up and head down time between 1/2 inch and 1/4 inch are going to be about the same, if not exact. Same thing for vaporization and stuff like that. Inside the technology table, there are 2 different fields that you're going to adjust that are going to be dependent on the material thickness and the process that you're going to be cutting with. And those are going to be your pierce time and your feed rate. So your pierce time, how long does it actually take to pierce into the material? If you're doing a slow pierce, a fast pierce, or anything like that, depending on your machine, what the capabilities are, as well as the feed rate. So this is going to be based on how long it actually, or how fast we're actually going to be cutting at. And that will be dependent on the different material and thicknesses and process that you're going to be cutting at. This also can be dependent on the area as well, as we'll see in the example that we're going to show. So let's go ahead and hop in the software and run through an example of how we would adjust some time calculations on a machine that we're having issues with the estimations that are coming out. All right, so now that we're inside of the software, what we're going to do is, like I said, we're going to run through how we would do a time calculation on an example. So in this instance, we're going to use this sheet right here. So we only have one layout. Usually the smaller the test, the better. That way we can start ramping it up from there. So feel free to do one part and run it and see how long it takes. Make sure that's dialed in, and then start ramping it up by doing a full sheet, and then start adding stuff like etching and other processes and stuff like that, and start really getting that dialed in and making sure everything is dialed in. So like I said, your planning and your quoting is very accurate. So what you're going to do is going to go ahead and post this out, generate your code, send this to the machine. Make sure that you save this workspace because you do want to come back to this. You don't want to have to leave this up so you can come back and change it. So you can just go ahead and save the workspace, do your other jobs, come back to it, and start this time calculation study from here. And then what you're going to do after you post it out, you're going to print your reports. Typically the ones you're going to want is the layout detail and the detail analysis, both of which will give you some pretty good information. The layout detail is going to give you an overall time on how long it's going to take to cut the nest, whereas your detail analysis is going to be the one that is going to break down the numbers into their more specific values, such as the total amount of pierce time, total amount of rapid time, all that stuff will be included here. So what we're going to do is go ahead and print those. So we'd hit print here, generate those, and then head out to the machine. So once we generate a report, we would have our time. So in this case, we're going to hit report. We're not going to generate a report in this example, but you normally would. And what we're going to see is that the total time it's going to take to cut this is about 1 hour, 11 minutes, and 52 seconds. So with that information, we have our workspace, we have the code ready to go at the machine, and we have the estimated time of how long it's supposed to cut at the machine. From here, we're going to go run at the machine. And let's say that you ran it, and you got about 54, 55 minutes, somewhere around that range. So you come back to the software, and we see that we had about 1 hour and 11 minutes. So we're a little off. We're not too far off, but just enough that depending on how many parts, it can scale over multiple nests. So if I had 10 different sheets, that 10-minute variation is 100 minutes right there of time that could be lost. So that does compound. It might not sound like a lot for one nest, but over time it will compound and start pushing projects back and will cause a lot of issues in the long run. So what we're going to do is we are going to start at our first location, which is going to be adjusting the post. So as I mentioned, the post is very important to make sure that we adjust the values that are our static values here. What that means is going to be values that no matter the material thickness and all that stuff are going to be exactly the same. So what we're going to do is go ahead and edit this with Notepad++, and we're going to open this up. Feel free to open this up in just regular Notepad. You don't have to have Notepad++, just anything that you can do to adjust values inside of here and inside of some text document editor. It could be Word, but typically we use Notepad++ or regular Notepad. And then you're going to look for the cutting time calculation section. So it's going to start on line 410 and go down from there. The first thing we're going to see is our cutting time calculation is going to be on, so 1 equals on. We'll start going down the list and look for rapid feed rate. So we have millimeters, inches, so the first one's going to be millimeters, second one's going to be inches. And we're going to adjust that, and let's say that it's 8,000 even, and we're going to save that. And again, the rapid feed rate is going to be the exact same no matter the material thickness or the process that you use. So all of the values in here are going to be static across the board for every material that you're going to be cutting. So if I'm cutting 1/2 inch or 1/4 inch, the rapid feed rate, so when the head picks up and rapids to another hole, is going to be exactly the same. Same for feed rate for vaporization. In this case, on this nest, we're not doing it, so me changing this value is not going to do anything. This again would be one of those things that you would start to ramp up. So in this particular nest, all I'm doing is straight cutting. If I wanted to do a time study on vaporization, I would add some vaporization onto the nest, and then that way I can start adjusting this value to get a more accurate cut time on that. Again, these are going to be very dependent on your machine. So for instance, vaporization is usually going to be for your lasers. And we do have stuff in here such as punch, which again, we're on a laser, will not affect anything that we're doing. So we'll go down this list, see if there's anything else. Nothing else that I'm seeing is stuff that we would need. However, we do get to the head up and head down time. So in this case, it's saying about 1 second for the head up and 1.5 seconds for the head down. In this case, we looked at the machine. It actually took, let's say, about 1/4 of a second. Now, 1/4 of a second from 1 second does not seem a lot. However, when you are raising and lowering the head throughout the sheet, it does add up. So it's very important to make sure that is accurate as possible, not to just leave that there thinking that a second doesn't mean anything. Then we'll go down, nothing else here. We do have process change time, which that's going to be if we're going from etching to cutting or vice versa, or any other process. However, in this instance, we are not etching, so we will not have to worry about that. Again, we would do another time study with parts with etching on it, and then adjust that here. If your machine has an exact stop, we'll adjust that there, and I don't really see anything else. We do have a setup and unload time, both of which are set to 10 seconds. For this example right here, we're just going to go ahead and leave that alone. However, if you did want to have a different setup time, so that's going to be how long it takes for the operator to load the sheet, load the program, and hit start. The unload time is going to be how long it takes for them to unload the sheet, take off all the parts, and get the sheet off. So we budget enough time for the machine to be ready to go for the next start of the setup time of the next program. But in this case, we're just going to leave these both at 10 seconds. So again, we're going to want to make sure we save. Go ahead and minimize that for right now. Shouldn't have to go back into that. Again, the only time that you'd have to go back into it is if you started adding more processes, so the time that it takes for vaporization and stuff like that. However, again, across the board, no matter the material thickness and stuff like that, all of these should be exactly the same no matter what material thickness and process that you're going to be doing. So usually that should be one of those things that it is done once and not have to edit it again, because it should be dialed in, unless for whatever reason it is manually changed to the machine for better quality purposes or whatever reason. For the most part, those should not have to be adjusted again. So now that we made those changes, what we're going to do is go into our report, and we're going to see that our time now is 1 hour and 3 minutes and 30 seconds. And really the only things that we changed was a slight variation in the feed rate for the rapids, as well as the head up and head down time. So even though those changes were about a second or less in difference, over the length of the whole entire sheet, it can make a huge difference. So it's very important to make sure that you dial that in. So now that we have that change, we're still a little off. We're about 8 minutes off our 54 to 55 minute mark. So what we're going to do is adjust the other half of this. So our post value are our static values that will not be dependent on thickness and material and stuff like that. So that's why we edit those first and see where we're at. The technology setup, on the other hand, is going to be material dependent. So in this case, we're doing mild steel 1/4 inch. So what we're going to do is go inside of here, and as you see, I only have 2 materials in here. You might have, very well might have a whole bunch of other ones. But it's very important to make sure that you are focused on the material group. So for instance, this is our mild steel, and that's what we're going to be cutting with. Whereas we have our cold rolled here, and cold rolled can be categorized as a mild steel, as long as this is in the material group mild steel, which in this case is not set up. So this does happen all the time. So make sure that your material are in material groups unless they are material groups already. But it's very important to do that because what we're going to say is that anytime that we cut cold rolled steel, it's going to be a mild steel, and it's going to use the cutting information for mild steel. So if you have 10 different forms of mild steel, instead of having to do a case study on each one of those and a whole bunch of time calculations and cutting a whole bunch of sheets and getting that information, all you need to focus on is the main material groups that you're going to be cutting. So in this case, it's going to be mild steel. So next we're going to go to our machine parameters, down to our machine, and we're going to look at our primary tech. So inside of our primary tech, we're going to have our different material groups on the left side and different columns depending on the process, the quality, and the process parameters. So in this case, we're looking at mild steel. So you can use these filters up here, make it nice and easy to see. And what we're going to see is that our process is 4, 10, 11, and 12. It's not very important to know what these values are. However, general rule of thumb, anytime that you see 10, 11, 12, any of those values, those are going to typically be your etching processes, whereas any value 5 or less, or 6 or less, depending on your machine, are going to be your main cutting process. So in this case, we're on a laser, so 4 is going to be our laser cutting. Plasma is going to be 2, oxygas is going to be 1, and so forth. So what we're going to do is go again across the chart. So we're cutting mild steel. Our process is 4, so we do fit inside this process. And we're going to come across is this quality 1, 2, 3, 4, and 5. 5 is a manually set option. That's why it's in here for all these different options. However, our automatic lookup for our quality is going to be based off of 1, 2, 3, and 4. So what we're going to do is again go across. So once we get into quality 1, how we know if we're inside the quality 1 option is based on the area. So as you can see, we have different areas in here, and we're cutting 1/4 inch. So 1/4 inch in this instance would fit between the 23 and the 0.32. So we default to the lesser value, meaning we are using this guy right here. So what we're going to go across and see that our area is 0.6648, which means that if our part is bigger than slightly over 1/2 inch, more towards the 5/8 range over here, then we are going to use this feed right here of 110. If we go down to quality 2, we'll notice that on the 23 it's 0.166, which means that any part between 0.166 and 0.6648 are going to be cut at quality 2, which is a feed rate of 102. Now, in this particular nest, we don't have any parts that are going to be about that small. So really the one that we're going to be focused on is quality 1. However, if you do have parts that are smaller, it's very important to make sure you take these different qualities into account. So this is one way that you'll see quality. Another way that you'll see quality are charts that will have multiple of the same thicknesses. So you might see 0.23, 0.23, 0.23. And each one of those will have different values for their area, and that's how it's going to determine. In this case, each quality has their own chart. So we're going to come in here and we're going to look at the pierce time as well as the feed rate. So we're going to say that our feed rate, we pulled it from the machine, is about, I don't know, 150. And let's say our pierce time is about half a second on this. The reason that we're editing this is because it is a 1/4 inch material, and it fits within this quality right here of this area. Other machines, such as, let's say, this plasma, for instance, so go to the primary tech here, show all the materials. You'll see that the process parameters right here will have the different amperages, whereas there's also not quality. So each machine is going to be very unique and very important to make sure that you know how to read your chart. And make sure that you're adjusting the correct material. If you're not adjusting the correct material and the feed rate, depending on your machine, you might be messing up the feed rate callouts we send to the machine, or you're going to not have very accurate cut times still, and it's going to not change anything. You'll also notice on this particular machine that for our 10 and 11, which again in our etching processes, are going to be in their own chart. So in this particular machine, the feed rate for the etching on this plasma machine is going to be different than your regular cutting, whereas on the laser, all the different processes are on the same line. So going back to the primary tech, again, mild steel, process 4, area of 1, quality of 1. We'll go down to that. Again, we adjusted the feed rate and the pierce time. These are the two values that you're going to have that are going to affect the cutting time and cutting calculation. So now that I click OK, I'm going to go to my nesting detail, I'll hit my report, and we're going to pull this up, and we are almost there. So what this tells me is that we have went inside of the post, we have went inside of the technology setup, that there is some value that I might not have correct. So I might have pulled the wrong feed rate from the machine, I might have pulled the wrong piercing time. So it could be a number of things. So what I'm going to do is at this point, again, just double check your numbers. And let's say that I found out that my feed rate was incorrect. Again, I'm going to come in here to my technology setup, machine parameters, to my laser, primary tech, mild steel 4.2. Let's say that instead of 150, I was wrong. It was actually 200. That's what we're actually cutting at. And this could be for a number of reasons. It could be that your charts that you pulled were outdated. It could also be that when your machine operator actually runs the program of the machine, they're actually dialing up the speed to make it cut faster. So this is also something that's very common. So making sure that you have a good relationship with your operator on how they're actually cutting it. We do have some operators that will just hit go and take whatever feed rates in the machine, and some of them know better and are feeling comfortable with actually adjusting that feed rate. They might not do it on all parts, but they might do it on a couple. And if that's the case, try to take an average of what they're doing. So if they ramp it up to 200 and the machine starts at 150 and they only do it on certain parts, maybe put a feed rate in there of about 175. Try to get as close as possible as you can, because there are a lot of variables that can affect the time. So again, we're going to go back to our report and check it now and see what time we're going to get. All right, and there we are. We are at the 55-minute mark, that 54-minute mark that we were looking at, estimated out the machine. You're probably not going to get 100% dead on, so that is to be expected. So don't worry if you're not 100% on what you're getting at the machine. The main point is to make sure you're as close as possible, You can have plus or minus time. It happens. So don't worry about that. But just making sure that I eliminate instances like this where instead of putting out an hour and 11 minutes, I'm putting out 55 minutes. That's about a 16, 17-minute difference on just this one nest. And if you have those 10, 15-minute variations between 10, 20 nests, over time, it's just going to start building and your times are going to be very off, and you're not going to be able to plan accordingly. It could be the difference between being able to schedule another job that same day, or it could be, like I said, the difference between over quoting or under quoting. So it's very important to make sure you have this stuff dialed in. So from here, now we have this dialed in, we're all set, and we would move on to our next material thickness and process. So again, in this case, we only have mild steel and 1/4 inch. We don't really have a different process because on this particular machine, it's not asking for a gas, it's not asking for nitrogen or oxygen. But for instance, if I was on my plasma machine, I might want to do a time calculation for when I'm cutting 1/4 inch with 120 amp versus 150 amp, and getting the two different time calculations there and having those dialed in depending on which amperage that I'm using. So there's a lot of different variations as far as the different materials can go, so it's very important to make sure you take that into account. Another thing to consider is the area. Like I said, it's very important that if you do have small parts, so for instance, if this part did fall within that smaller range, it could be one of those parts that needed to be adjusted. So if I had a full sheet of these, it would actually be correct. So it's very important to make sure to take that into account. All right, that's all we have for today. Thank you for your time and for joining us. Now's the time if you have any questions to go ahead and enter those in the chat, and we'll get those answered for you. If no one has any questions, then as always, if you have any questions later on or over any other topic, definitely feel free to check out our other webinars, or reach us at our support line at 513-595-2002 or at support@sigmatek.com. And as always, there are articles and other webinars on our connect.sigmatek.com website, so definitely go out there and check those different files and resources there, webinars, forums, as well as different articles on many other common topics, such as this one.
All right, I'd like to thank everybody who's coming out today. Also, for us. As a reminder, this session was recorded, so you will be receiving a copy of the recording in the next few days. It will also be up on our Connect site along with all of our past webinars, as well as supporting articles. Our next webinars, as Andrew mentioned, are on the 24th, which is a Wednesday at 1 p.m. That webinar is on clamps and clamp safety zones. We also have a few additional webinars planned in April. The first one is April 14th, which is on basic report edits, and then on April 28th, which is on remnants. Those are all Wednesdays, and they're all at 1 p.m. So if you would like to go ahead and register for those, they're up on the site now. You can register. Other than that, we do have a survey to be answered once the webinar is closed out. If you use the point that you would find to fill out that survey, that really helps us when we plan future webinars, as well as how we go about the information in the webinars. We make these videos for you guys, so the more information we can get from you on what you would like, the better the webinars can be for you guys. So at this time, it looks like there's one more question in there. If you have any questions, now is the time to do so. Otherwise, I'd like to thank you all for coming out, and I hope that we see you on the Clamp Safety Zones webinar on March 24th.